So today we want to do some more with sine, cosine, and tangent, but we actually want to apply them, use them in ways that sine, cosine, and tangent are really used. And they're used a lot for what we call surveying, measuring long distances, measuring large heights. A lot of times you see those guys on the side of the highway with their orange vests on and a little tripod, and they're looking through something. They're measuring angles so that they can use sine, cosine, and tangent. Now, as a quick review yesterday, we've got to remember all of our trig ratios. That's what we call them, sine, cosine, and tangent. There's a quick, easy little name that I learned. Sounds like an Indian princess name, SOHCAHTOA. The Indian princess, SOHCAHTOA. Kind of like Pocahontas, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. SOHCAHTOA. So that's always a good little quick thing that you can write at the top of your paper whenever you're trying to solve these types of word problems to help you remember your sine, your cosine, and your tangent, because it's going to become very important. And as the title indicates, we're going to be talking about angles of elevation and depression. Like I said, the guys with the tripod on the side of the road are usually measuring angles. If they're measuring the height of a building, then they're measuring how far up they have to look to see the top of the building. They're measuring that angle so that they can have an angle for their triangle, so they can use their sine, their cosine, or their tangent. All of these angles, angles of elevation and depression, are based off of a horizontal, the horizon. Horizontal. So if it is an angle of elevation, that means that from the horizontal, we are looking up. And so this would be our angle of elevation. If, however, the wording says angle of depression, that means that we're looking down from the horizontal. Okay? So an angle of depression would go down this way. And so this would be an angle of depression. So depending on your word problem, make sure you pay attention. But do be aware that angles of elevation and depression have to be against the horizontal. That's the big deal. So they always have to be against the horizontal. So let's look at some actual examples where we're going to have to remember sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. You do have to know that. All right, so let's take a look at an example problem and see how this would work out. It says Kara's kite is flying at the end of 35 yards of string. Her end of the string is 1 yard off the ground. The angle of elevation to the kite is 50 degrees. What is the height of the kite to the ground? As I have said before, I have to see something. So just reading these words doesn't really help me too much. So first, I am going to draw a picture. So here's Kara. And Kara is flying a kite. Let's make it a pretty color. I like colors. Alright, so we've got Kara and she's flying her pretty little kite up here, blowing in the breeze. And so here's some pieces of information that they give us. They tell us that her string that goes up to her kite is 35 yards. So that we know. Alright, so we know that that is 35 yards. We also know that the end she's holding from here to here is 1 yard. So it's 1 yard off of the ground. Alright, so what are we interested in? What's the question asking us? What is the height of the kite to the ground? So we are looking for a height of the kite. And they also give us an angle of elevation. Now, if you remember, angle of elevation means going up from the horizontal. So the only way I'm going to get a triangle out of this is here's my horizontal. So the angle going up from my horizontal is my angle of elevation. So it must be 50 degrees. And we are looking for the height. Now, here's the thing. If this is 1 yard over here, this is 1 yard over here. So when I do my trig, and I find my x, it's actually going to be finding this height from here to here. So I am going to have to remember to add in that 1 yard. That's why they gave me that piece of information, is because the triangle is actually up here. So once I find that side, I'm going to have to remember to add that 1 yard in from how high her hand was up off of the ground. So looking at this, we need to remember all the stuff we learned yesterday about triangles. This is the angle I'm interested in. So I need to label all of my sides. This is my hypotenuse, because that's the long side, always across from the right angle, is always the hypotenuse. But if this is my angle in question, going straight across, that makes this my opposite, and this my adjacent. So when I look at this problem, I've got SOHCAHTOA. The sides that I know, the sides that I'm interested in here, I want to know this side, that's the opposite, and I know this side, that's the hypotenuse. Which of these three has O and H in it? And the only one with O and H is sine. So I'm going to write the sine definition. Sine of an angle is equal to opposite over hypotenuse. Let's fill in what we know. We know the angle is 50 degrees. So sine of 50 degrees is equal to, the opposite side is our missing piece, it's our x, and our hypotenuse is 35. Well, x is being divided by 35, so in order for me to solve, both sides need to be multiplied by 35. So I'm going to multiply both sides by 35, and these will cancel out. And this is where your calculator comes in handy. All we have to type into our calculator now is 35 times the sine of 50. Yesterday we worked on where all those sine buttons were, cosine, tangent, and all that. So type in 35 times the sine of 50. And hit enter. And I get that x is equal to 26.8. Now this was yards. Now, be careful. That's not the answer to our question. That's because this word problem did have this little bit here that her hand was 1 yard off of the ground. So we do need to remember to add that +1. And so the kite is actually 27.8 yards off of the ground. Alright? So that's how that works. See how a picture helps. I'm not an artist. It doesn't have to be a great picture. I just need to see where all the pieces are. So let's try another one. A helicopter is rescuing a would-be mountain climber. The helicopter is hovering, so there's an angle of depression of 35 degrees. So I'm going to try and highlight some of the important stuff here. So we've got an angle of depression, and it's 35 degrees from the helicopter to the climber. The bottom of the helicopter 12-meter ladder is hanging even with the climber. How far does the helicopter need to move horizontally to be directly above the climber? Alright, so we've got some important things there. I highlighted all my numbers so I could see where they were. And now I need to draw a picture. So, got a helicopter. These are always funny. Helicopter. I need a little thing back here. There we go. Okay, that looks like a helicopter, right? Alright, so we have our helicopter, and the helicopter has a ladder. And it hangs straight down, one of those nice chain rope-like ladders. Alright, so we've got a ladder hanging out of our helicopter. And then we have our would-be mountain climber, and they do tell us that the bottom of the ladder is even with the mountain climber. I'm going to say he's fallen down over here somewhere on the side of a mountain, hanging on for dear life. So the bottom of my ladder is even with my mountain climber. And then they tell us that we have an angle of depression. So angles of depression, we said, had to be going down. So it's going down from the helicopter, down to the mountain climber. But we said that angles of depression had to be with the horizontal. So that means that this is the angle of depression, not this one. And that's the biggest temptation most students have. They want to draw the triangle over here and make this the angle of depression, but that is not true. The angle of depression has to be against the horizontal line, not the vertical line. So that means that we're going to have this line going across here, and this is our angle of depression. And they said that that was 35 degrees. So I've got 35 degrees for my angle of depression. Now the interesting thing is, if this is 12 meters, the ladder is 12 meters, that means from over here, from this horizontal line, down to the mountain climber is also going to be 12 meters. And then we have to figure out, what are they asking us for? Are they asking us what this distance is? No, they said, how far does the helicopter need to move horizontally to be directly above the climber? So they need to know, how much does this helicopter need to scoot over so that it will be directly above the climber so the climber can grab the ladder. Makes sense. So this is the side that we're looking for, this side over here. So let's do some labeling. This is our angle that we are interested in, which horizontal and vertical lines, that makes that the right angle. So this is our hypotenuse. Directly across from the angle is going to be our opposite, and then that means the only one left is the adjacent. So the ones that we know, I know the opposite side, I want to find the adjacent side. So think about it. So, ka, toa, SOHCAHTOA, the only one that has opposite and adjacent in it is the TOA. That's tangent. So then, again, we're going to write it. The tangent of the angle is equal to the opposite over the adjacent. Plug in what you know, solve for what you don't know. I've got 35 degrees, so it's the tangent of 35 degrees is equal to the opposite, which is 12, over the adjacent, which is what we don't know. It's our x. Alright, so this we just need to solve. Now, this is a great little trick I'm getting ready to show you. Anytime that what you don't know is in the bottom of the fraction, not like last time. Last time it was, here we go. Last time it was in the top of the fraction. This time it's in the bottom of the fraction. These two can just switch places. Alright, so I'm going to rewrite this as x is equal to 12 over the tangent of 35. The reason being is we're going to have to multiply both sides by x to get the x out of the bottom, and then we divide by the tangent to get the x by itself, and it's just easier to always remember that these two just switch places. So that gives me one nice simple thing to type into my calculator. So I'm going to do 12 divided by the tangent of 35, and I'm going to get that x is equal to 17.1. 17.1, and all of this was in meters. So 17.1 meters is how many meters that the helicopter needs to move over to be on top of the climber.